Guess who's back? Back again. Finney's back. Tell a friend. Guess who's back? 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 Hey there, all you cool cats and kittens. Mr. Finn back here to take you through another day of quarantine with 8.2 geometric sequences in series. Hope everybody out there is doing well. So last time I was on the video, we were talking about arithmetic sequences in series. It's going to be kind of some similar stuff, except with geometric, there's a key difference. So arithmetic, we're adding or subtracting. Geometric, each term goes from one to another by multiplying or dividing. Typically, we'll say multiplying. By the same value. And so for arithmetic, we call this value the common difference or the generator. For geometric, we're going to call it the common ratio or the generator. So I like to use generator a lot because we're generating from one to the other. So the same value called a common ratio, or I'm going to stick with the same term of generator. Later on, we're going to look at a geometric series, which is just like the arithmetic series, which is the sum of a geometric sequence. Okay, so we can see in these two boxes here, here's a sequence. We can see it's progression 3, 9, 27, 51, and 143, or excuse me, 153, which you can surmise is multiplying by 3. And then for the second one, taking all those terms and add them together to find the sum. Okay, so just like we were doing before, we are going to determine the generator and find the next three terms. So the first one, we're going from 1 to negative 1/2 to 1/4. So there's some different ways. If you don't see what the pattern is, one way to find what the generator is to take one of the terms and divide by the previous one. So for example, if we take negative 1/2 okay, and divided by 1, or if I take 1/4 divided by negative 1/2, that comes out to be negative 1/2. So when I multiply the next term, so if I want the fourth term, fifth term, and sixth term, I'm just going to keep multiplying by negative 1/2. So 1/4 times negative 1/2 is going to be negative 1/8. Then you're going to have 1/16. Then we multiply that by negative 1/2. That is going to be negative 1/32. So when we go to find the equation for the nth term, it's going to be just like we're doing with arithmetic. I want two things. I want the generator, which we have. It's negative 1/2. And I want the zero term. Well, our first term is 1, and we're multiplying by negative 1/2 to go forward. So if I want to go backwards a term, I can either divide by negative 1/2 or I can multiply by negative 2. Okay, and that's going to give us negative 2. So this is the way we write it for geometric. T of n equals our zero term. And then in parentheses, we're going to put in our multiplier, our generator, which is negative 1/2 to the n power. The reason why we write it like this is because it's an exponential equation. The exponential equations that we've learned from the past looks like this. Okay, where A is your zero term, B is your multiplier. So you try out number 2. So press pause, try number 2, find your multiplier, so that way you can go for the next 3 terms and then see if you can find the equation. So to go from one item to the next item, looks like our generator is 3. Okay, so when we find our 4th, 5th, and 6th term for this, so when I take 45 times 3, it's 135, and then multiply that by 3, 405, and multiply that by 3, 1,215. So to find the equation, I have my generator. I just need my zero term. So 5 times 3 gives me my list. So I'm going to do 5 divided by 3 to get my zero term, which I can just leave it like that as a fraction, 5/3. Okay, so 5/3. Then our multiplier is 3 to the n power. So let's take a look at when we have a table. Let's take a look at when we have a graph. So again, the things that I need is I need to know how I'm going from one item to the next for my generator. I need my zero term. In this first example here, I have my zero term. I just need my generator. So I can take any of these numbers, okay, any one that I choose, and I could divide them. I could take like 1,600 divided by 2,000. When it comes out to be a nice decimal, you're more than welcome to use that decimal. So this can reduce down to 4/5. Okay, or also 0.8 would be fine. And we have our zero term, so don't need to calculate anything there. So T of n equals 3,906.25 times our multiplier to the n power. Okay, so again, the biggest difference between arithmetic and geometric: arithmetic, we're adding and subtracting; geometric, multiplying and dividing. Let's take a look at the second one here. So we have some gaps and we don't have the zero term. So we're going to do kind of similar before. We're going to take one of these terms. So I'm going to take 72. And I'm going to divide it by the previous item. Well, there's nothing in this spot here. However, there is a 50 right here. So I am going to divide those two, which is 1.44. So we have to account for these blanks. So to go from 50 to 72, I got to go 2 spots. When we talk about multiplication for geometric, if I want to get to the common ratio or the generator for this, I'm going to do roots. So how many spaces we have determines what root we're going to take. So since there is 2 spaces, we're going to take the second root, or we're going to take the square root of 1.44, okay, which is going to be 1.2. So to find the zero term, there's there's one way to find the zero term. So going down the list, we're multiplying by 1.2. So to go backwards, we're going to divide by 1.2. Okay, so we're going to take 50 divided by 1.2, which comes out to be this really long decimal that repeats. So what you can do to account for that, once you put in your calculator, when you take 50 divided by 1.2, you get like 41.6666. It repeats. Press the fraction button for this, so that way we can get it back into a fraction. Just looks a little bit neater this way. And when you do that, the zero term is 125 over 3. All right, so we have our zero term now. We have our multiplier, so we can do T of n equals 125 over 3 times 1.2 to the n power. For the last one, we have this graph, and you can see how it's starting to curve. So that tells you that it is geometric and not linear for this. So what I would do for this is I would create a table. So we don't know the zero term because we don't see where it's crossing the y-axis. We know the first term. If you look at the increments here, we're going from 0 to 20. So that means everything is moving by 4s for this. So 4, 8, 12. So the second one here is going to be 36. And then the third one, when you count all those marks, if you go from 100 and count up a couple spots, it's going to be 108. So once you guys define the multiplier for this, then find the zero term, then write the equation. So press pause and try it out. All right, so for the generator, you can take any of the numbers and divide by the previous one. So I can take 108, divide by 36, which is 3. Okay, and if I take 36 divided by 12, it's also 3. So to find the zero term, moving forward, I'm multiplying by 3, so I'm going to take 12 and divide by 3, which is 4. Okay, so y equals the zero term, 3, excuse me, not y equals, you can use y equals, it's the same thing. T of n equals 4, 3 to the n power. So just like before, the reason why we like to write these equations is because it makes finding different terms in the sequence a lot easier to do rather than listing every single thing out. So let's take, for example, let's take A and B here. We're going to find the sixth term. You can absolutely list things out. Sometimes a little bit easier than just to plug it in. So when I look at letter A, I can see 3 is my zero term. My common ratio or my multiplier or my generator is 9 over 10. So I want to find the sixth item. So I'm going to take 3 times 9 over 10 to the 6th power. Make sure that you guys are always using parentheses around this stuff so that way the calculator does order of operations correctly, especially if you're putting it in all at one time. Okay, and this is going to give you 1.564323. Okay, you guys take a look at letter B, okay, and calculate that for me. So t to the 6th power equals negative 2.5 times 1.5 to the 6th power. Go ahead and throw that in your calculator. And the sixth item in this sequence is negative 28.4765625. Actually, let's just say T of 6 in there. Okay. So we go to find some other items. So if I want to find the 20th item of 3, 9, 27, we can go ahead and list everything out if you want to, or we can turn around and write an equation for it. So there's 2 things we need. We need our generator. Generator is pretty easy. We could take 9 divided by 3, which is 3. Zero term. Okay, so I'm going to take the first term, which is 3 divided by 3, which is 1. So T of n equals 1, 3 to the n power. So if I want to find the 20th item, I'm just going to plug 20 in for n. Okay, throw that in your calculator. It's going to be a big number because you're taking 3 to the 20th power. So the 20th item in this sequence, 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. Okay, so 3,486,784,401. Okay, try to write the equation for number 6. All right. So we need our multiplier, then we need our zero term. So for the generator, I could take any of them. So I'm just going to go 8 divided by 2, which is 4. So then for the zero term, I'm going to take 0.5, okay, divided by 4. Okay, when you do that, that's going to give you 0.125, or 1/8 if you want it to be 1/8, but it's a decimal that we can easily work with. So T of n equals the zero term times the generator to the n power. All right, so now we're going to write the equation for the nth term, where we know the fourth item is 5, and the multiplier or the common ratio is 6. So we don't have a list for this. We can make one. I mean, we're only at the 5th item. We can start dividing everything by 6 to get down to our zero term. Or we can do this. So we don't know our zero term. I'm going to call that a sub 0. Okay, 6 to the n power. So here's what I do know. I know that the fourth item is 5. Okay, so I know the fourth item to this is 5. So I'm going to put 5 in here for T of n. Still don't know the zero term, but I know that when I take 6 to the 4th power, whatever my zero terms I multiply it to, I'm going to get 5. So I'm just going to work this out. I'm going to solve for a sub 0. So 6 to the 4th power is 1,296. I'm going to divide this. Okay, and again, you can leave it just like this. So our zero term is 5 over 1,296. Okay, no real reason to go to a decimal for this. So when I go to write the equation, T of n is going to equal 5 over 1,296 times our generator of 6 to the n power. Okay. All right. So the last part of this, before we get into doing the series for this, is to be able to find the list. And it all comes down to finding the common ratio or the generator. So remember the graph that we just did a little bit ago, excuse me, not the graph, the table we did a little bit ago that has some spaces in it. This is going to be the same thing. So I'm going to take the one item, 1,250, divided by the previous. And there's a lot of blanks in between before we get to 2. Not a big deal. So I'm going to take 1,250 divided by 2, which is 625. So I'm going to count the spaces. So 1, 2, 3, 4. So to be able to get to my multiplier, I'm going to take the 4th root of this. So in your calculators, if you have your TI calculators, you can find the 4th root button. There's ways to do it, but if you remember back what we've done earlier this year, is we can take this to a fractional exponent. So this is going to be the same thing as doing the 4th root is the exact same is doing 625 to the 1/4 power. So when you take 625 to the 1/4 power, you get 5. So when I go back in to fill this table, I'm going to take everything times 5. So I'm going to take 2 times 5, which is 10. And then 10 times 5, 50, 250. And then to make sure that this is correct, take that 250 and multiply it by 5. That's 1,250. Okay, so you guys try out number 9. Divide the 2, then see how many spaces are in there, and that's going to be the root that you take it to. All right, so for my generator, I'm going to take 512 divided by 0.5. That's going to be 1,024. So there are 1, 2, 3, 4, 5 spots, okay, before you get to 512. So I'm going to take either the 5th root of this or 1,024 to the 1/5 power, which is 4. Now I'm going to go back in. I'm going to multiply all these. So 0.5 times 4 is 2, and then 8, 32, then 128. And then one of the most important things to do is to take that 128 times 4 to make sure that it equals 512. Okay, all these blanks are called the geometric means. All right, last thing we're going to do is we're going to calculate the sum of a finite series. So depending on how many is in the list. There's 2 formulas. So first formula here is when we know the first term. We know R, our common ratio, or our generator. Okay, and then we also know the number of terms. The second one is used best when we know the first term. Okay, we know the last term. Now let's do this. So then we also know our common ratio / generator. Okay, and the difference with this formula is we also know the last term. So the difference between the 2 formulas, the first formula, we know the number of terms. The second formula, we don't know the number of terms, but we do have the last item. So for something like number 1, to begin with, if you look at it, what we know is we know the first term. We can get the generator for this, but we don't know how many items there are yet, which we'll find. And then, I take that back, we do. We know there's 8 terms, but we don't know what the last term is. We could calculate it, but no sense of doing that. So that's going to tell us to use the first formula. Okay, so we're going to do the sum of 8 items is going to equal the first item, which is 14, times 1 minus the common ratio. Well, to go the generator for this from 1 to the next, to the next. If I just take -7 divided by 14, it's going to be -5. So we're going to put in -5 to the 8th power divided by 1 minus -5. It is extremely important that we are using parentheses when you're putting this in the calculator, because if you put this in without without parentheses is going to give you a negative number, which we're taking it to an even power. So it's got to be positive at the end. So put this in your calculator. Let's see what you come up with. And then I'll show you what I have. So there's going to be 14 times 1 minus, because there is another negative sign there, minus 390,625 divided by 6. Okay, so this is going to be 14 times negative 390,624 divided by 6. And then when you go ahead and finish, when you complete this, it's going to be negative 911,456. Okay, is the sum of all this. Because we're going from positive to negative, you can also kind of see that the negatives are getting bigger than the positive numbers as this progresses. Okay, so let's have you guys try out number 2 because, well, let's go through number 2 together, because this is the one where we're going to use the alternate formula. I know the common ratio, but I don't know how many items are in here, so I'm going to use the second formula. Okay, I don't have how many items, but I have the first item, the last item, and I can get my generator. Okay, so for the generator, we could take something like 2.5 divided by 0.5, which is 5. So just plug it all in. First item is 0.5 minus the last item, times our generator of 5, 1 minus 5. All right, so when I go ahead and I start to calculate this, I'm going to get if I just do the top all the way together, it's going to be negative 122070312 over negative 4. And we divide those two. The sum, whatever the number of items is, because we don't know for sure. Looks like 30,517,578. Okay. Have you guys find number 3. So you're going to have to determine which formula to use. So go ahead and press pause for this, and then calculate the sum for this series. So this is another one that we have to use the second formula because we only know the first item, the last item, and we can find our common ratio. Okay, so when I find the common ratio, we're going to take any of them. We can take negative 2 divided by 1, 4 divided by negative 2. Either will come out to be negative 2. So I'm going to plug this in. First item is 1 minus 65,536 times negative 2. 1 minus negative 2. Okay, so when you start to complete this, it looks like up top you're going to get 131,073 divided by 3, which gave me 43,691. All right, so let's do the last two. So given a sum and a common ratio, and if you know how many items are in the list, or you actually don't even need that because we have two formulas for it, we're going to find the first three terms. So this is going to be using the first formula, and the reason why is because we don't know the last item. We're going to use the first formula because we know the common ratio and we know the number of items. So that formula, S sub n equals A sub 1, 1 minus r to the n power, 1 minus r. So when I plug all this in, what I'm looking for is my first item, so that way I can use my generator from there. So I'm going to plug 13,116 in for S sub n because this is the total sum. I don't know the first item, but I do know 1 minus 3 to the 7 power divided by 1 minus 3. Okay, so when I take 1 minus 3 to the 7 power, so this is what I have so far. That's going to be A sub 1 negative 2,186 divided by negative 2. Now I'm going to divide those two. I'm going to take negative 2,186 divided by negative 2, 13,116 equals 1,093 A sub 1. And then just going to finish this off algebraically by dividing. So the very first item in this is going to be 12. So when I make out my list, my first item, second item, third item, first item is 12. I'm going to take my generator, which I know is 3, and multiply it to give me 36. And then multiply that, 108. Okay, you guys try the next one. Find the first three terms of the geometric sequence where r is 1/2, n equals 5, S sub n is 19.375. Well, again, for this one, you should be using the second formula because we don't know the last item, or the first item, so we can't use that formula. So S sub n all right, so plug in everything that I know. The sum of this is 19.375. I don't know the first item, but 1 minus 0.5 or 1/2. I'm going to do 0.5 just to make the calculation easier, to the 5th power. Okay, divided by 1 minus the common ratio again of 0.5. Okay, so 19.375 is going to then equal A sub 1, 0.96875 divided by 0.5. Divide those two. Okay, so that should give you 1.9375 A sub 1. Then to find the first item, divide those out, and the first item is 10. Okay, so 10, our common ratio is 1/2, so then it's 5, and it's 2.5. So notice your list is getting smaller. So that's why the sum of this is 19.375, is not getting real big. It's actually is not growing by a whole lot. All right, everybody, that is geometric sequences in series. Hope you got something out of this. Have a great week, and we'll talk to you later.